hundreds of them. It isn't just that there are hundreds and hundreds of them, and somehow, someone has adjusted them just perfectly. It's the haunting truth that if just one of them were even slightly turned in any direction, it would render the accuracy of all of the hundreds of others irrelevant. It isn't just that there are hundreds and hundreds and hundreds of these dials. It's as if you just messed with one of them. It wouldn't matter about the precise accuracy of every single other one. What a strange, mysterious little floating blue and green ball we call home. Now, the general estimate is that our universe is 10 to the 27th power meters across. Once again, somebody measured. And the general estimate is that the smallest thing in our universe is a subatomic particle, 10 to the negative 26th power. Now, if you were to take an average of all human beings' heights, if you were to look on planet Earth, what's the average height of all human beings? And so you were to take babies, toddlers, preschool kids, hobbits, adults, you would end up average height of all human beings somewhere around 1 meter, making human beings the middle in size in the universe. And you're fascinating. How many of you can see me? Excellent. Encouraging, to say the least. Yeah, you have this visual cortex in your brain connected ultimately to the retina in your eye. 110 million cones, 7 million rods, over 1 million nerve fibers, all working in harmony so that you can see things. You have over several 100 billion brain cells, neural connections somewhere in the trillions. Every second, your brain doing roughly 1 trillion computations, and no one of those brain cells are the same. In any given 1 or 2 second period, your body has just produced 2 to 10 million brand new red blood cells. You have 100 million white blood cells being stored right now in your bone marrow alone, which raises the question, if your body is producing new red cells and white cells to make you, and producing these cells at the rate of hundreds of millions every couple of seconds, how does your body know to make more and more and more of you and not somebody else? Every single one of those cells, hundreds and hundreds of millions of cells, has roughly 6 feet of DNA coiled inside of it. It's like a map. It's a code that tells your body who you are and how to make more of you. If those DNA strands were stretched out into their 6-foot length, and then all of them in your body were put end to end, it would be 80 billion miles of instruction. It would go from the earth to the sun and back 400 times. Your body, down to the 100th, billionth, millionth of a cell, is hardwired to be you and no one else. But those cells are actually made up of a smaller component called an atom. Now, if you wanted to see an atom with your naked eye, you would need to be 1 billionth of an inch tall. And you'd have an incredibly high voice. The earth is to an orange as an orange is to an atom. If we were to count the number of atoms in 1 drop of water, if we were to count the number of atoms in 1 drop of water, it would take every single person on planet Earth counting 1 drop, 1 atom every second for the next 20,000 years. Atoms are small. Thank you. It's been great. Now, if you were to take apart an atom, if you had those kinds of tools in your garage, you would discover that an atom in the center is made up of neutrons and protons, and then you would discover that circling around the center very, very quickly are what's called electrons. Now the question is, what do you mean by circling? An electron orbits an atom several billion times every second or so. They're quite busy. Now, if you have 2 bonded atoms with all of these electrons orbiting around their centers, in any given second between the 2 bonded atoms, there would be roughly 3 billion collisions. Here's what this means. Take a picture of an atom. Take a picture of the same atom a second later, And while that atom will be in its basic essence the same atom, it will have changed drastically in that passing second. Take a picture of an atom. Take a picture of an atom a second later. You don't know exactly what it's going to do. Now, in the 1890s, a group of scientists, led by a man named J.J. Thomson, said, what if we could take apart an atom? What if we could split an atom? What if we could come up with a thing that makes atoms? Well, if we could split an atom down to the thing that makes up an atom, well, what if we could split it enough to get down to the basic building block of matter? Well, if we could do that, if we could get down to the thing that makes the things, that makes the things, that makes the things, that makes everything, well, then we could explain why everything is how everything is. So they began splitting an atom. They quickly discovered that an atom can be split into a smaller substance called a quark. Atoms are made up of quarks. But then they discovered you can split a quark. And then they discovered the thing that you can split a quark into, you can split that. And then they discovered that thing that you can split the thing that you can split a thing to make a quark, they can split that. So the quest kind of went whoop, a little bit off track. And to this day, they're saying they agree that they've identified at least 100 subatomic particles. You got your bosons, gluons, nuons, leptons, mesons, endless lists of these unbelievably small things. If you've ever heard the term quantum physics, quanta simply means packets of energy. Because at its core, these atoms and these quarks are simply these bundles of energy. Now, when you get into the subatomic realm, things get very, very strange. They have discovered that a quark can be in one place, can disappear, and appear in another place without traveling the distance in between. They have discovered that a quark is capable of what's called simultaneous duality. They have observed quarks, one quark that is capable of being in two different places at the same time. In 1949, a scientist came up with what's called Bell's theorem, a personal favorite of mine. Bell's theorem was essentially this discovery. You can take a quark, an atom, and split it in half, and put one half in New York, and you can put the other half in San Francisco. If you take the quark in New York, and you reverse the spin of its electrons, at that exact moment, the half in San Francisco, its electrons will reverse their spin as well. If you've heard of the butterfly effect, that's essentially a popularizing of Bell's theorem. In New York State, in 1997, they discovered an exotic meson, and we all know how exotic mesons can be. This meson appeared for a trillionth of a second, and then it was gone. They don't really know where it came from, and they don't really know where it went. And so you have these unbelievably brilliant subatomic quantum particle physicists saying things like, I don't know. They have discovered a subatomic particle called a lepton. And the general consensus is that leptons do exist as individual subatomic particles. The only hitch is they've only been able to observe leptons in communities of 2 and 3. And so they say, yes, we understand that this is a single lepton. The problem is we only find them existing in groups of 2 and 3 oneness. And so the Newtonian understanding of cause and effect has simply taken a beating with quantum physics, because you take a picture of an atom, you take a picture of the same atom a second later, they don't know what it's going to do? Well, the assumption was always there's an element of predictability